The next chapter that we're going to be doing is the digestive system. And you have a pre-lecture worksheet that you're going to be working on for class after spring break that will go over the digestive system anatomy. However, for this part of the lecture, what I would like to do is look at the digestive system physiology. Specifically, I want to look at where digestion is occurring when we look at what's being broken down. And so I have this simple illustration. You have on Blackboard, you can print out 4 of these sheets. We're going to be working on filling out each one of these. The first will be on carbohydrates, and that'll be introduced in just a second. What I want to do now is I want to quickly go over the parts on this sheet so you know what each little squiggle that I have drawn here represents. So when you take a look, this obviously is going to be the way that you're going to get into the digestive system. So there's the mouth, and then this is a salivary gland, which connects to the mouth. When food swallows, it goes down the esophagus and ends up in the stomach. And from the stomach, it gets pushed out into the first part of the small intestine, which is known as the duodenum. Here is the oh, that's not the pancreas. My apologies. This is the gallbladder. This is the pancreas. And as we get farther down in the small intestine, we have the jejunum. And at the end of the small intestine is the ileum. Okay? So those are the parts, and then I'm going to show you where different enzymes are going to be coming through and what each of those enzymes are about. Okay, when we look at the digestive system, one of the things that is most important for you to be aware of is the fact that there is ingestion that occurs. And ingestion is bringing things into the mouth. So it's anything that's coming in through the mouth. And then the second function of the digestive system is digestion. And digestion is mechanically or physically breaking down food into smaller units. Eventually what we want to do is these smaller units, we want to break them all the way down into something called monomers. And we're going to look at that in just a little bit. But monomers are the smallest unit that we want to worry about. So we're going to look at the 4 major food groups. You've seen those before when you look on the back of your labels on things that you eat. You see carbohydrates, you see proteins, you see fats, and we're going to add one more, which is nucleic acids. So we're going to start with carbohydrates and look at how that gets digested, and then we're going to move into the other 3. So we're going to begin here with carbohydrate, change pens, carbohydrate digestion. Okay, so coming into the mouth, what's being ingested is going to be starch. Starch is going to be coming into the mouth, and there is an enzyme that's going to be released from this salivary gland. That enzyme is called amylase. And amylase is going to begin to work on starch and begin to break it down, along with your tongue and your teeth are going to start mechanically breaking it down. this amylase that we've talked about here is going to begin to do the actual chemical breakdown of starch. So the starch is going to move from the mouth down the esophagus and into the stomach. And along the way, some of the starch is going to start to be broken down into smaller carbohydrate units. It may be broken down into oligosaccharides, or possibly even being broken down into even smaller monomers. Depends how much time it has to work on the starch before it hits the stomach. Okay. There is no starch digestion that occurs in the stomach. It's just simply too acidic. The enzymes there don't function for starch digestion. And so whatever's been digested here is still broken down here, but there's nothing new happening. And so as we move out of the stomach and we end up going into the first part of the small intestine, and this part of the small intestine is called the duodenum. It's a U, duodenum. We have more digestion that begins to occur. So this organ represents the pancreas. And the pancreas releases an enzyme as well. This is called amylase 2. And the amylase here is called pancreatic amylase because it's coming from the pancreas. And the amylase that's coming up here is named, you guessed it, salivary amylase because it's coming from the saliva in the salivary glands. Okay, you find it there. So the starch is coming through. This pancreatic amylase is going to continue to break the starch down. And so the starch now, instead of being starch, is going to be broken down into something called, let me move my paper here so you can see what's going on. So as we continue to move down here, this starch is going to be broken down into oligosaccharides. It's also going to be broken down into disaccharides. And eventually, when we'll show you, we're going to add a few things here, it's going to be broken down into monosaccharides. Everything still on there? Yep, all still on the paper. So monosaccharides. So amylase begins to break it down into these oligosaccharides. So the starch that has come from the mouth, down the esophagus, through the stomach, is being broken down by amylase into oligosaccharides. And that's being done by another set of enzymes. And these enzymes are found here on the cells of the intestine. If you look at the cells of the intestine are made up of columnar cells. And on the edge of the columnar cells, you have little tiny cilia. Actually, these are microvilli, my apologies. And when we look at all of the microvilli together, they're referred to a lot of times as the brush border in the intestine. And so the enzymes that are attached to these microvilli are called brush border enzymes. So in the intestine here, you can see we have this little brush border, and I'm exaggerating the size of those microvilli significantly. But on those microvilli, you're an enzyme, Saccharide Dase. And you know these guys are enzymes because when you look at this ASE at the end, anytime you see that ASE ending, you know that you're dealing with an enzyme. So the oligosaccharidase breaks down the oligosaccharides into disaccharides. And when we look at the disaccharides, there are actually 3 different types of disaccharides. Those disaccharides are sucrose, again that's a U, and they are maltose, and lactose. You may be familiar with these. Sucrose is table sugar. Maltose is the sugar that you find in grains. And lactose is the sugar that you find in dairy. So the people that are lactose intolerant are unable to break down this particular disaccharide. Again, found on the brush border of the enzyme, and while I'm just showing it to you in one little spot, this brush border is actually found throughout the duodenum and the jejunum, and even a bit in the ileum. You're going to find some more brush border enzymes here, and these brush border enzymes are going to be sucrase, which breaks down sucrose, maltase, which breaks down maltose, and lactase, which breaks down lactose. And so these enzymes are going to break down these disaccharides into monosaccharides. So they're going to be broken down into monosaccharides. And monosaccharides, there are 3 that you have in your body. The 3 monosaccharides that you have are glucose, galactose, and fructose. Okay, so these are the types of monosaccharides that we have. And when we look at these 3, the glucose, the galactose, and the fructose, these 3 are the monomers for carbohydrates. All carbohydrates will eventually be broken down into one of these 3, glucose, galactose, or fructose. Once you have broken them down this small, now they can actually be absorbed into the body, and so they move from the small intestines. Okay, so you have these monosaccharides that are in the small intestine, and they move from the small intestine into the capillary beds. Let's add this into the digestive capillary beds, and right into that bloodstream. They are going to be absorbed there, either by diffusion or by co-transport with sodium. Okay, I'm not so worried about this for the exam, but you definitely should be comfortable with this, that they move into the capillary beds, and so they are going right into the bloodstream. Okay. And remember, when we're looking at these capillary beds, that's going to be taking it to the liver, and then the liver will do the metabolic processes that it needs to be able to give that energy from that carbohydrate to the body.